In this video, we are going to take a brief journey through the life and legacy of Sir Godfrey Hounsfield, a brilliant inventor whose work revolutionized medicine and saved countless lives. Born on August 28, 1919, in a rural village in England, Godfrey Newbold Hounsfield grew up tinkering with machines on his family's farm. He had little formal education beyond secondary school, but his curiosity led him to join the Royal Air Force during World War II, where he honed his skills in radar technology. After the war, he worked at EMI, yep, the same famous company for records and the Beatles, where he applied his engineering prowess to medical imaging. In 1979, Hounsfield shared the Nobel Prize in Physiology or Medicine with Alan Cormack for inventing the CT scanner. He was knighted in 1981 and passed away in 2004 at age 84, leaving behind a legacy of innovation. Now let's dive into his groundbreaking invention, the computed tomography or CT scan. Before Hounsfield, doctors relied on flat x-rays which often missed details hidden in overlapping tissues. Hounsfield's idea, inspired by his radar work, was to use x-rays in a whole new way. The patient lies on a table that slides into a donut-shaped machine. An X-ray tube rotates around the body, firing narrow beams from hundreds of angles. Detectors on the opposite side capture how much radiation passes through different tissues. Dense areas like bone absorb more, while soft tissues let more through. A computer then processes this data using complex algorithms to reconstruct detailed cross-sectional images, like slicing a loaf of bread to see inside without cutting it open. The first CT scanner, installed in 1971 at Atkinson Morley Hospital in London, took hours to scan a brain and days to process, but today's machines do it in seconds, diagnosing everything from tumors to fractures with incredible precision. Central to his technology are Hounsfield units, or HU, a scale Hounsfield devised to quantify tissue densities in CT images. It is based on how materials attenuate X-rays compared to water, which is set at 0 HU. Air, being less dense, is around -1000 HU, while fat is at about -100. Muscle is about 40, and bone up to 1000 or more. Metals like surgical implants can reach 3000 HU. This standardization allows doctors worldwide to interpret scans consistently, spotting abnormalities like bleeding or cancer by their unique HU values. Godfrey Hounsfield's humble beginnings and relentless ingenuity transformed diagnostics, making the invisible visible and turning potential tragedies into treatable conditions. His work reminds us that true innovation often comes from unexpected places.